wondered how to do SAT math problems in 10 seconds or less? If so, in this video, I'm going to go over some 10-second solutions to SAT problems to help you guys totally crush the SAT math section even faster than you ever thought you could. My name is Brooke. I've coached students to perfect scores on the SAT and ACT. I've also scored perfectly on the SAT math, the ACT math, the PSAT math, and the GRE math sections. So get ready for some math ninja skills. I'm gonna share my secrets with you guys in this video. You can also find more of them at SupertutorTV.com, where we have a couple of courses for the SAT and the ACT. I've also got a couple of books on the ACT math section you can check out at Amazon. You can also subscribe to our mailing list, which is totally free. SupertutorTV.com/subscribe will keep you in the know of any deals we have or anything awesome we have going on our channel. And we're on social, so make sure that you follow us here on YouTube, as well as TikTok, Instagram, Twitter. What am I forgetting? I'm not sure. Facebook? You guys aren't on Facebook. That's for parents. Let's do some super fast math. Cool. So caveat, to teach you how to do math super fast, it's going to take me some time. So in order to explain these super fast hacks, I'm going to have to slow down so that you understand the math behind them, so that when you see them, boom, you are like a lightning bolt. Cool? Awesome. And if you just want to see me do math fast, well, we have a video for that too. I'm going to go over several of these. First one that I want to cover is what I call the slope shortcut. This one's really cool. It comes in handy. I'm going to show you guys a problem from a real SAT, and we're going to get started here. First up, I have this problem here. It says in the XY plane above, line M is perpendicular to line L. Which of the following could be the equation of L? So how am I going to solve this in 10 seconds or less? Well, I'm going to use a shortcut that I like to call the slope shortcut. A few things that we need to learn before I run the problem. So I'm going to run it in 10 seconds after I show you guys kind of the technique that I'm going to use, and then you can see how I implement it in 10 seconds or less. And maybe you guys can sit here and try to figure out the problem on your own while I talk. So the first thing that I'm going to talk about is perpendicular lines. Remember, perpendicular lines have slopes that are opposite reciprocals of one another. This is a fact that you should know. So for example, if the slope of the line that we're given is a over b, that means the perpendicular line is going to have a slope of negative b over a. This is ground rule number one. You have to know this kind of before going into this. That's not my 10-second tip. That's a different tip, but this is outside information that you have to know first. So I'm just going over that so you guys know that. That's number one idea. Number two is my slope shortcut. So whenever we have an equation of a line and it's in slope-intercept form, it's really easy to find the slope or compare the slopes of the lines, right? But sometimes lines aren't in slope-intercept form. Sometimes they're in standard form. And standard form is when we have ax plus by equals c. So whenever we have an equation in standard form, you might think, gosh darn it, I have to turn this into slope-intercept form, and then you end up doing by equals negative ax plus c, and then you divide everything by b, and you divide by b, and you divide by b, and then you get y equals negative a over b times x plus c over b. Okay, now I'm done, right? But you see how this takes a little bit of time. Well, there's a faster way, because as you can see, when I solve this into slope-intercept form, m is always my slope, and m is right here. And you can see here that m is negative a over b. And that's a fact that you guys can memorize to totally speed up your slope problems on the SAT. I find that it comes in handy. About every other SAT that I do, this trick comes in handy for me. And so here's what it is. When I have something in this form or a form that's very similar to it, I know that the slope is always negative a over b. So that means when I look at this problem and I see all these answer choices, granted, these are not in standard form exactly. They're almost in standard form, right? Because it has this piece here, this piece would have to get moved over here in order for all of these to be in standard form. But that's kind of a moot point, and it doesn't really matter, because the truth is, these in this form, the a and the b aren't going to be modified at all. And when I look down, I can very quickly see that. So that's kind of the first piece of how I'm going to solve this in less than 10 seconds, is I know that all of these are all my a's and these are all my b's if it were in standard form, okay? And then I know if I want to compare their slopes, all that I need to find their slopes is negative a over b, okay? So now I have all the components I need to do this problem in 10 seconds or less. So let's start that timer, and I'm going to show you guys how I do it, and then I will explain. Okay, are we ready? Da, 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 da. Here we have 3 over 5 is the slope. That means I need a slope of -5/3. A over B is 5 over 3. Make it negative, it's A, and I'm done. Okay, so that was a less than 10-second solution. You can see I got a little lucky because the answer was A, but I know what I was looking for because I know I need a slope of -5/3. That means A over B with a negative sign in front of it has to be -5/3. So I need a 5 and a 3, and everything has to be positive, okay? I see this negative, that doesn't work, and this isn't 5 over 3, so I instantly know that C and D are wrong. And I can look through that pretty quickly and get this essentially in 10 seconds or less. Cool? Cool. I hope that made sense to you guys. Awesome, awesome. One other quick note on this one. I also very quickly, when I was assessing the slope here, how did I find that slope if you were wondering? I just count rise over run. Now it's really important that you know the scale of the graph. The SAT loves to mix these up or make this 2 and this 1 or pull like mind games with you. So always make sure this is 1 and 1 before you start counting boxes. Otherwise, this might take more than 10 seconds. You can't do every math question in 10 seconds, right? Okay. Next problem. Let's get on to the next problem. Okay. Tip number 2. If you know a factor, you know a solution. If you know a solution, you know a factor. We're going to look at this lovely question number 13 from an October 2019 PSAT. So how do I solve this in less than 10 seconds? Some of you are like, I already got it, Brooke. Awesome if you do. We're going to solve this because I know whenever I see something factored, I know a solution. So this is basically a tip that goes kind of 2 directions, which is if you know a factor, you know a solution, and if you know a solution, you know a factor. And this is just a good fun fact to keep in mind whenever you're doing polynomial problems on the SAT or the ACT. So here, when I have x minus 4, what that means is that I have a solution at the opposite sign of whatever this is, right? And this has to be 1x. Otherwise, what I would have to do is set this whole thing equal to 0. So there's 2 kind of ways that you can know that it's positive 4. One, I just have it memorized that if this is 1x, and then this is another number, I switch the sign and that's my solution. So if this is x plus 2, my solution is -2. If this is x minus 1, my solution is +1. So I can very quickly figure out what all these solutions are simply by flipping the sign on each of these. I could do it in my head. I don't recommend doing a lot of math in your head. I recommend writing as much as possible because that's where careless errors come from. But you can see really quickly, I get 4, -2, 1, and I need the product of the solutions. That's -8. I'm done. Woo! That was fun, wasn't it? That was like a 5-second solution. So that's really cool. If you're wondering why that's true, it's true because of the zero product property, right? The zero product property states that if we have a bunch of factored pieces, that if their product equals 0, then one of those has to equal 0, one of those individual pieces, right? So you can see the traditional way to do this is to set each of these equal to 0. And this certainly works, but you can see how this is more time consuming. And again, if I just have memorized that when the x has no coefficient, I can just take this number over here and flip the sign to get the solution. It's a much faster way to kind of do this math. So here we get x equals 4, here we get x equals -2. Obviously, this won't always work, right? Sometimes you're going to have something like 2x minus 3. And if you have that, then what you have to do is you can set this equal to 0. You can also, like in your head, kind of understand that what you're going to do is push this to the other side and then divide. So this is going to be 3 over 2. So you can also flip the sign on this and then divide it by this if you want to speed it up and you have something that has a coefficient in front of the x. So you can see this won't always work super, super fast, but in this case, it does work super, super fast because I can just go, oh, I need the product of the solutions. That's going to be 4, -2, and 1, and that's -8, and I'm done, right? Super fast, 10-second solution. Awesome. Hope you enjoyed that. Now, one more tip on this that also can help you get to 10-second kind of solutions is this goes the other direction too. So if I have a list of a bunch of equations at the bottom here, and they give me 3 solutions, and they say which of the following polynomial equations could have these following solutions, you do the same thing in reverse, right? So if they told me 4, -2, and 1 are all solutions to a polynomial, which of the following could be that polynomial? I'm looking for factors x minus 4, x plus 2, and x minus 1, because those match the solutions. Make sense? Awesome. Okay. So the next thing that I'm going to teach you guys is going to help you solve kind of these exponential growth problems. I'm actually going to pull one from a packet that's on our online course here, but these are also on the SAT itself. The following equation represents the population P of T of a certain strain of bacteria in a petri dish measured after T hours. Which of the following best describes the relationship between the population of bacteria and the number of hours that have passed? So you can see that just reading that takes a few seconds, But when I see this equation, I can read and understand this equation in about 3 seconds if I know what an exponential growth equation looks like. So I'm going to go over the basic equation for an exponential growth problem. And this is just a really handy thing to know. So exponential growth, I can represent, you can use whatever letters you want, but I'm going to use A equals P times 1 plus R to the T. And now I'm going to tell you guys what each of these pieces are so that when you see something that talks about exponential growth, boom, you can identify it super duper fast, okay? So A is the amount or the total amount that we have going. And this could be if I have a bank account that has a sort of interest, this is the total amount that my bank account has in it. If I have some bacteria in a petri dish, right, A could be the total number of bacteria in that petri dish. Whatever it is, this is my total amount. P is the number that I start with. This is my starting number generally. And obviously there's modifications to this, and I'm teaching you guys the simple one. I get into like more complex problems on our online course, and there's also more complex problems obviously on the SAT, but I'm just gonna do the basic one because that's the one that you can kind of do in 10 seconds. So this is gonna be our starting number, and then 1 plus R is basically the percent shortcut applied to this number, and I'll talk about that in a second. So this R here is going to be a percent in decimal form. So if I increase something by say 25%, then that makes my R 0.25, okay? So this is the decimal form of the percent, okay? And then finally we have T, and T is the time where the time period matches the compounding period, okay? And if you're wondering what's a compounding period, the compounding period is how often we compound the amounts. So for example, on a bank account, you might have an account that compounds your account monthly. And if you're compounding your account monthly, that means this would be the number of months up here in this exponent place, right? That would be every time you compound, you need to have the exponent running. So this exponent, this whole piece would represent the number of months. But sometimes you'll be compounding monthly and they'll give you in the problem y in years, and then you have to make adaptations to that. So I'm not going to get into those more kind of complicated problems at this point. Again, I'm just going to try to teach you the basic thing. When the time matches the compounding period, meaning if it's monthly and this rate is monthly, these two kind of have to match. Whatever the rate's time period is has to match this time period up here. And if for some reason they don't match, you're going to have to make adjustments, but I'm not going to go into the adjustments ones right now. I'm just going to get into the simple ones. And this is like for simple stuff, okay? So we have the amount, we have the starting amount, we have the percent increase in decimal form. Now, if we wanted to do percent decrease, this would just be 1 minus R. Why is this true? This is true because of percents. Remember that if you have percents, let's say you want to increase the cost of something by 25%. Let's say that something is X. What I would do is I would do X plus 0.25X equals my new amount, right? But what am I essentially doing here? This is 1.25X, isn't it? So this is what I call a percent shortcut, just doing 1.25X. It's a percent shortcut because this is always what happens whenever you do percent increase or decrease, right? You start with 1x, which is basically like 100% of the amount, and then you add or subtract a percent of that amount, and you can basically add the coefficients immediately and get this shortcut of if I wanted to increase x by 25%, I just do 1.25x, right? If I wanted to decrease x by 20%, I could do 1 minus 0.2 times x, which is 0.8x. So this is just a percent shortcut, but that's what goes into the exponential growth or decay equation. So it's good to kind of know percents up and down. We have a really great overview video where I go into this more in depth on our course if you have to be on our online course. But I'm going to get back up here. That's why that's kind of true. But if you know percents well, this won't be that bad. So here's our equation. So what this means is when I look at a problem like this and I see this, I instantly know what each of these pieces are, right? I instantly know this 2.1 is basically 110% more every t period, right? I know that that's what's happening. If t is in hours, this means every hour I increase 110% more. Now I also can make this times, right? This also means I multiply this number times 2.1 after every hour, right? After 1 hour, I multiply it once by 2.1. After 2 hours, I'm going to multiply this twice by 2.1, et cetera, et cetera. Because I know this formula, I know exactly what's going on. And the other thing that's kind of also good to just memorize and know is that this number, when I get this number, this 1 plus r, this 1 minus r, and that's when we're talking about percents, can also be thought of as times. So for example, if I have a petri dish of bacteria and the bacteria double every hour, that would be this, A equals P times 2 to the H, right? And this would be my 1 plus r. I'm not dealing with percents, I'm just doubling it. So if I'm just doubling it or tripling it or something like that, you can just put the number there that's double or triple or whatever. Remember, doubling is the same as adding 100%, which makes sense because my r, or my percent, is 100%, and in decimal form, that's just a 1. So this is 1 plus 1 if I think about it in percent form, but oftentimes when we say we doubled something, we don't say we increased it by 100%, we just say we doubled it. So same thing, also good for you guys to know, but when you come with all this knowledge to the table, that's how you can do a problem like this in literally 10 seconds. So now start your engines, guys. I'm gonna do this in 10 seconds. Get ready, on your mark, get set, go. So I see this. When I see a problem like this, I don't even actually read all that. I go straight to the equation and I look for the question. We want the relationship between bacteria and number of hours. And so I'm looking for exponential growth. So I know not linear, exponential, exponential. And 219 times larger? No, it's going to be 2.1 times larger because remember, I said this is what twice, right? 2.1 times, and I'm done. And I know it's D. Now, I probably should slow down and really carefully read these. I have a 98% chance that I got this right in less than 10 seconds, but I might want to go back and just read these carefully, and I'm going to do that right now to just double check, which is the relationship is exponential since the population is 219 times larger than in the previous hour. That's crazy. We're multiplying by 219 each hour? No, because this, if this is 0, I don't multiply by it all. I multiply by 2.1 over and over and over again after each hour, right? The way that this looks if I wrote it out, after 1 hour, for example, I do 219 times 2.1. After 2 hours, I do 219 times 2.1 times 2.1, right? And I just keep multiplying by 2.1 over and over again. That's what this is about. And because I know the times larger is always this, right? Like when I talked about the bacteria, how if it's double, then there's a 2 in those parentheses, the 1 plus r would be 2. Because I have that knowledge and I know that's how this equation works, I can look at this and like get this problem super fast. So hopefully you guys, that gave you some information on this is how these exponential growth equations work, at least the simple ones. Again, there's harder ones, there's more complicated ones out there, but this gives you an overview that hopefully gets you started. Cool, awesome. I hope you guys like this video. If so, please give it a thumbs up. Subscribe to our channel if you haven't yet. If you have any awesome 10-second solutions, post them in the comments below. Let us know your favorite hacks, and I will see all of you next time on Super Tutor TV. Bye-bye.